Okay, so good morning. I will talk today about the recent developments in the Hurd. I will provide some introduction to the Hurd, but focus then on some new things that we have developed. So to begin with, I would like to explain that it's all about freedom zero, and that is being able to run application to run the program for any purpose. One thing that is a pain quite often is that you have to ask the system administrator for something, to format something, to fdisk something. Uh, all these tools are hidden in /sbin, which you are not supposed to use. Why am I not supposed to use these tools? There's no reason. That is, I have access to some network. I can open sockets and things like this. I can access my home, store things there, and there's no reason I shouldn't be able to do stuff in there, whatever it is. And it's also the freedom to innovate. You can want to use another file system that would be experimental, for instance, that would be able to store meta attributes and then sort files according to this. And there's a lot of things that you could do. Or it's just a question of your own workflow, and you go to another machine, you don't have the software, but you don't either have the features that you would want. You can experiment with combinations of things. And also it's to get free of the misbehaving programs. That is, you can trust some programs, others you don't want to. And if you're not root, you cannot do this. You cannot use jails and things like this. You have to be root to use these. I've received an email some time ago asking me, is it possible for my VPN to make some applications use it and other applications not use it? It's not clear that it's possible on Linux. And actually, it's a well-known issue. The VPN itself shouldn't go through itself. It should go through the normal route. And yet, even with root capacity on Linux, it's really not easy. On GNU Hurd, it is possible. I will show you, and it's quite easy. And you don't have to ask root for anything. So just to list the kind of things we are interested in. So you can mount your own file, so you can access an archive or a remote file like SSHFS or things like this. You can experiment with file systems or just open an ISO image. You want to extract a file from the ISO image, you just mount it. Accessing your network, so I mentioned VPN. If you want to access the inside of a VM, in QEMU you have the user mode emulation. It's a pain to use because you have to establish a forward for TCP forwarding, etc. You may want to experiment with sound. You have some stacks like Jack, etc. But it's not really integrated in all the applications, and you may want to apply some effects, etc. So, as I said, I will introduce a bit the architecture of the Hurd, and then I will discuss about the recent developments in the console, the network, some nice translators that we have. I will tell a real nice story about debugging, and then present the current state of software and hardware support. So, just a reminder, in the Hurd we have a kernel which mostly only memory and inter-process communication, and then we have a few servers, so X2FS, BFINet, OAT, proc. So X2FS is the file system for slash. BFINet is the TCP IP stack. OAT knows the UIDs of the processes, and proc knows the PIDs and things like this. It manages signals, etc. So I'm a user, I'm running a shell and CP, whatever. And what happens is that the shell discusses with X2FS to have access to the file system. And X2FS knows which permissions the shell has through the auth process. And this is an interesting thing for subherds, which I won't discuss today, but there was a talk 2 years ago which was discussing about it. The interesting thing is, for instance, that if a server crashes, it's not a problem. You would get an error message which is called computer bought the farm. L'ordinateur a cassé sa pipe in French. So it's just an error. It's not something of the death and you have your whole system completely down. Of course, if it's the slash file system which is crashed, well, then you have a problem. But if you have your slash home or whatever, if you are making experiments, you do this in another file system, and if it crashes, not a problem. The TCP/IP stack is the same, and it's even better. If the TCP/IP stack crashes, well, you have lost all your existing connections, then you can restart it, and it will go fine. It's easier to debug. You can run GDB on X2FS. If you have a bug in X2FS, then start a session on some volume, and then you can GDB it. That's really nice. And for profiling, you can just use jprof, etc. And you can dare things. I will show you. The Hurd console has dynamic font support, which permits to print Chinese in text mode. That's quite nice. And the kernel only handles the trivial stuff. So for instance, a nice thing you can do is using FTPFS and ISOFS to access a file inside an ISO image which is distributed over FTP, over the network. So I can show you this. No, not this one, that one. Yes. So I'm a mere user, and one thing I usually do on my system is have a /FTP : the translator for FTP access. So I just set it. So there are two translators here. One is a multiplexer for the name of the server, and the other is just FTP. So one deals with domain names and the other one just FTP. So if I have a look at the directory, there's nothing. If I have a look at ftp.gnu.org, it takes some time because it has to establish the connection, but there is a cache, so it's faster after that. And then the nice thing is can set trans. The nice thing is that you can actually type a URL. It does work. So it takes time because ISOFS analyzes the file. I don't know if the network is working so nice. It seems to be going through at least. And the thing is, ISOFS doesn't download everything. It just downloads whatever it needs to get the structures of the file system. And slash is easy to get. Maybe it has the whole tree of files, I don't know. But it just works. And you can store this permanently. So for instance, my FTP is permanently the FTPFS translator. And another example is the signature file is actually a translator, and so each time I look at it, it's another instance of the run translator, which just runs something. So when I actually open the file, a command is run, and I get the output. So instead of having each and every email program being able to do this by itself. So how does it work? It's simply that libc does not make system calls. There are a couple system calls just to allocate memory, but otherwise all file system operations, sockets, etc. goes through the translators. So when it opens a file, instead of talking with x2fs, it talks with the isofs, and then isofs connects to ftpfs, etc., etc. And so it's actually inside the libc. So it works with all the processes because they are supposed to use libc. It's a bit similar to what's it called, GVFS in GNOME, which is a layer in between I'm opening a file and I actually ask the libc to do it. So that's the way they did it, but it only works for GNOME applications. Here it's all the applications. And it works for everything. Just because everything is an RPC, so everything is interposable, and simply because we expose this in the file system, you can easily tune whatever you want. So there are some tools which use ptrace on Linux to achieve the same kind of thing, or they preload a library which interposes symbols and things like this. It's a nightmare to maintain. A colleague of mine does this, and it's really a lot of headaches. Fake root is actually extremely easy to do on the Hurd because it's just a mere virtualization of the getUID function, and so we have native fake root, which is extremely efficient. The cool thing is that everything can be virtualized and at a very fine-grained level, because you can decide this call I virtualize it, this other call, or maybe the whole TCP/IP stack I will virtualize, etc. And so the idea is that as a user, I have access to some place to store data. I have access to a TCP/IP stack, and then I pile over things of this. So for instance, I can say that, okay, /bin/sh is actually pointing to my bin sh, just because I have a translator in between which cheats. When it is asked for opening /bin/sh, it actually opens home /bin/sh. And you could say that /bin is actually pointing to my bin, where I have everything I want. So it's a bit similar to stow, nix, gigs, etc. Okay. So interesting thing, you could have the TCP/IP stack. You run an OpenVPN over it, and then you run a TCP/IP stack, your own TCP/IP stack over the VPN. Run FTPFS, and you get a file, but it is partitioned. So you start a partied translator, and then you get access to the volume in which there is an ISO, and then you open the ISO. It just works. The cool thing is that you don't have less power than root, simply because everything root does is using the virtualization layer of Hurd. So everything can be done. Of course, you don't have direct hardware access, but you can provide access to a translator which accesses the hardware. So for instance, you can provide access to dev ETH0 because you trust the user into not pushing bad frames and things like this. And still, with the IO-MMU that some machines have, you could actually give a PCI card to a process in a safe way. So it's actually more power for everybody, both root and non-root, because you can combine translators, as I have shown, if you invent new ones, and you don't have to do kernel programming. A lot of people are afraid of dealing with the kernel because, yes, it's really not simple to program. Here, it's just normal user-level applications. So, now what's new in the Hurd? I mean new like in 4 or 6 past years. So we have a nice console. There is the Mark console, which is extremely simple, and we have another console on top of this, which has a server client design, very similar to Screen actually. So the server part runs some TTYs, and so we run get TTY on them. And to access that server, we start a client. So for instance, we start a client with loadable drivers, so keyboard, mouse, and VGA. and so we can access the from the computer itself, but you could access that console from an encrypted client through SSH or whatever, a braille device, you never know. So that's how we make the Hurd accessible, actually. The keyboard driver, recently we have just made it use XKB. Instead of maintaining our own key maps in some format, etc., let's just use XKB and translate things. You wouldn't ever imagine doing that in a kernel. XKB is possibly has possibly some bugs, and then you crash the whole kernel just because you have typed the wrong key. I had a bug in there. There was a little bug there, and there was indeed a shortcut that would kill the console. Okay, the console gets restarted, and you continue working. The VGA driver, so it drives the board directly in text mode, but it has support for 500 glyphs, and so we still keep from 32 to 126 as ASCII, just for compatibility with virtualization of the machine and things like this. But the rest, we can allocate that dynamically from whatever font we want. So for instance, I have, oh no, it's not, but yeah, I will show you now as a user. I make it bigger. So when you log in, you have a GNU that greets you. That's nice. And it's text mode. And we have double width glyph support. So if I go to, which one was this? Local chooser. Which language? So Chinese. So we have Chinese showing up in text mode. Nobody will dare doing this in the Linux kernel, clearly. So now about the network. This was the status like 4 years ago. So we used to have the network drivers in the kernel, so exposing device ETH0, and then we have the TCP/IP stack, which is opening that and exposing itself in the file system as /server socket 2. 2 is just the number of AF inet, and then a browser opens this to access the network. Something that Zengda did some time ago was stuffing Linux drivers with the DDA layer in a process, and so it gets access to the hardware, and then it shows up itself as dev ETH0. And so we let PFINet access this and then expose as before. The cool thing with that is you can interpose a firewall. You could have the firewall directly in PFINet, but you can also make it separate, so that perhaps PFINet is bugged and it crashes, but you want to keep the firewall state or whatever. So this is quite simple translator. It just forwards packets. And more than that, so we have PFINet here. I start OpenVPN on this to establish a connection with the VPN, and this is exposed as a tune device in my home as a user. Then I tell PFINet, go open this and expose this as a socket for me. I can provide access to this to other users or not, as I wish. So how do we do that? So we first start the TCP/IP stack, actually. I will take this one. A bit smaller. So I'm creating a node and starting it, and I could have used the standard PFINet stack, but there's a bug I fixed yesterday, so I rather use my own PFINet. No, it's not there. Never mind. But I could have. So I tell it to, it's actually TCP IP stack which will create the tune device, and I tell it to use the IP that I know I will receive, and the gateway, right? So this is started. I can see that there are two of them. One is run by root and one is run by myself. So now, oh, sorry. I will start, no, it's not VPN, it's FDN. So I'm connecting to a VPN. So it's indeed complete. And now I will start a shell using that that new TCP IP stack. So I'm telling replace server socket by server socket in my home. And there's a problem with DNS because I cannot access the DNS here from my VPN, from where I will show up on the internet. So I tell it, okay, I also want to replace etcresolve.conf with my own resolve.conf. And so this is a shell which is using the VPN. So I can get gnu.org, and we have seen that things have gone through the VPN. All this as a user. And it's my own translators. At the time I wrote the slide, remap was not yet in the standard installation, so I was using my own shell script. Okay. Other nice things. So we have funny stuff like this. So you can access the inside of a tar file. You can access CVS as hierarchy of the commits. I never tried it, so I don't know how it shows up, but it does show up. XMLFS, you have the trivial XML hierarchy showing up. I don't think we have write access in that one, but it could be done. Mboxfs, you have your mbox file showing up as a directory, so you can actually translate dynamically from mbox format to maildir format. I've shown FTPFS, there's HTTPFS and GopherFS, why not? We have a libfuse replacement, so we can actually just use whatever fuse, not translator, file system, but for us it's a translator. We have seen the run translator, which permits a dynamic signature. NetIO is very similar to Bash dev TCP, except that it works for all processes. That's much nicer. And so you can cut, I will show you this. Do I have my socket IO? Socket IO. Yes, I have it, so I can cat socket TCP, FTP, GNU, all 21, and then I get the prompt from the FTP server. So I don't know how many crazy things we can do with this kind of thing. You can pipe something and whatever. We have NSMux, so if you forget this part, you can find inside an HTML file through the XMLFS in the body of the HTML file everything that is called foo. But it's tedious to start the XMLFS translator, etc. So you have a shortcut by starting NSMux as a translator of /. When you use the shortcut, NSMux redirects the opening of the file through XMLFS. And so instead of opening the file from /, it starts an XMLFS translator telling him, open that file and give me the result, and then we can give that to find, which will be able to find things in there. Union mount is just the same as on Linux. Not much to say. So now, a real life scenario which I was quite happy with. of course, you get X2FS corruption for whatever reason. And the problem was that X2FS was crashing when I would open the volume. And I didn't know why, so okay, let's start E2FSCK. And E2FSCK wasn't able to fix the problem. Just because it was actually a bug in the Hurd part of X2FS. And how I found out that is just starting GDB on it, find where it is crashing. Okay, that's the problem. So I've added a check in X2FS to clean that thing, and then I could restart my X2FS. It was fine. And so the cool thing is I didn't get any system crash and have to reboot, and as long as I haven't properly fixed the thing, have to reboot again. I just restart my translator, see it crash, okay, GDB, and debug. Unfortunately, it wasn't as a user because the volume was on the disk, the hardware disk, but I could have done this as a user. For debugging, it's preferable to start GDB as a user than as root. Okay, so now about support for software and hardware. So recently we have had JCG working and GNAT, so both Java and ADA. GCC Go is ongoing. We have a Google Summer of Code on this. Basically, the issues we are meeting is that it has its own thread library, and of course you have all kinds of scary details to fix in there. So we are working on it. We have spent quite some time fixing test suites in Perl, Python, etc., etc. So for instance, in Perl there are maybe 0.1, I don't even remember, maybe 5 tests over 2,000, 3,000, I don't remember, which are failing. So mostly it's just POSIX corners, some details that nobody would care about except test suites. So it's quite nice. About software support for translators, most of the translators I've shown are written in C, but now we are using libpthread for translators. It took some time to manage to convert, but now it's done. So we can use whatever programming language you want, provided that you have bindings. I know there are bindings for Perl. I don't remember whether there are some bindings for Python. Do you remember? Somebody started it, but it was hit by the libpthread issue, but now there's no issue anymore. So we could have translators in Scheme, in whatever, in Epsilon. About the hardware support, so for now we still have a 32-bit kernel for x86 only. Somebody tried to make an ARM port, but he didn't spend so much time, and we didn't hear about him, so it's probably just stopped. We have a start of a 64-bit support. That is, the kernel boots completely. It's completely converted. Now we have the choice. We can start a 64-bit version of userland. It will probably be easier to keep the 32-bit userland and simply RPTs between the kernel and applications between 32 and 64. It's a matter of doing it, and then everything should just work. The idea is that then the kernel can easily support a lot of memory, even if processes only have a 4 GB addressing space. There are not so many things that need 4 GB of addressing space, mostly linking WebKit, things like this. Since we still have some architectures which are only 32-bit, it's not yet a problem because this kind of issue happens on other systems, so people find solutions, so it's not a pressing need. But supporting a lot of memory, yes, it is a pressing need. So I've said we use the Linux 2632 drivers for network boards, so this provides us with quite a lot of drivers. Not all of them are buildable, but most of the ones we need are just fine, and it's in a userland process. The very nice thing about this is that, of course, these drivers are GPL2 only. The Micro-kernel is BSD mostly, and the translators from the Hurd are GPL2 and plus. So this is a kind of managing to push the things we don't want to write them, to rewrite them. It has a license which may pose problem. Well, we put that into a process, separate process with well-known interfaces, so there's no licenses issues. And if it goes wrong, okay, we kill it and restart. For network boards in particular, it's really not a problem to kill the driver. That won't shut down the connections, so it's fine. So we have IDE, of course, Xorg is running. Of course, a lot of drivers require DRM acceleration, so these ones can't work, but Visa does work, so that's fine enough. For SATA devices, we have an HCI driver, which is quite small but just works, which also provides us with a 2 terabyte disk support. Which is fine enough for now. The problem is that it's at the interface layer that we have this limitation. So we will have to implement another interface. It's not really a problem, it's just a matter of doing it. We have Xen support, so the Micro-kernel can be started inside the Xen hypervisor. So it only required a change in GNU-Mark. The patch was like 5,000 lines, and it was mostly the drivers, of course, and the little bits here and there in the kernel. This provides us with an assurance of being able to run the Hurd on whatever machine Xen supports. We don't have USB, we don't have sound. USB is really a problem, I believe, because you always use USB sticks or external USB drives, so it has to be done sometime. Sound is less a requirement. A lot of people are asking for it because for everyday use you want to listen to music. Again, it's a matter of doing it. There are priorities to establish. About software support, I would say that it's quite stable, in that I don't even remember when I've reinstalled my boxes. That's years ago at least, probably 2008, something like this. And still, the Debian builds, for instance, keep compiling packages. That means installing packages, compiling it, and then deinstalling packages, etc. And this can go for a whole week before the machine hangs, essentially because there are some memory leaks here and there, which we should fix, but they are not so bad. You have to really compile a lot of stuff to be able to really hit the memory issue. So that's quite fine enough. We have a good part of Debian that builds. We haven't tested it all, but most of it should be working. We know that XFC does work. GNOME is almost working. GNOME applications are fine. GTK just works. It's mostly the desktop itself, so network manager, things like this, which are not necessarily working, buildable or whatever. But we are almost there. It's a matter of doing it. KDE is mostly the same. We have Firefox running. We have GNUMeric running, so there are some big applications which works. The installer for the Debian GNU Hurd is native. That is, we use the GNU Hurd to install itself, while in the past we were using Linux, and now it's really native, which simplifies a lot of things for the bootstrap. But it's quite a demand on the GNU Hurd, so we are quite happy that it works. About releases, we had a nice release on April 2011. I invite you to try it. It's quite nice. We have Hurd, which has been providing live CDs for some time. Their last release was on August 2011. At the moment, nobody is really working on it, but I guess it shouldn't be hard to continue what they have done. We have made a real release of Debian CD. It's not official for Debian, but for us it is really an official release. We call that a Wheezy seed snapshot. The thing is, we cannot ask Debian to synchronize on the Hurd while they are already struggling with the Wheezy release. So this is actually a seed snapshot, but most of seed at the time was exactly the same in Wheezy. So for almost all packages, that's essentially Wheezy, and some of them are seed. So that happened on May this year. And then maybe it's time to say, okay, it's working fine enough, let's tag it 1.0 and be fine. That's, yeah, we can do this. It's a matter of cleaning the manual installation stuff, etc. And it's feasible. So future work, there are several things in various areas. The Xen support at the moment is using PV that is not exploiting the virtualization capabilities of nowadays processors, and it's a bit sad. So Xen source has started work on PVH, which would be exactly like PV, except it uses that support. It's not done yet on their side, but when it's done, it will be easy to do this, because essentially it's about commenting out all the PV stuff for CPU virtualization and just use native stuff. So it should be easy. So I've mentioned 64-bit support, so it's in the to-do. I've mentioned language bindings for translators, so that it will be easier to make new translators. That really something that people can be happy with to experiment, to do crazy stuff. About the performance is not so bad. One of the issues is the disk access, because nobody took the time to implement read ahead. So that means if you are reading a file sequentially, it will be read bit by bit, and if the disk is slow, well, you are waiting each time. So it's a matter of implementing it. There are some work that have been done. We have to clean that and integrate. So for now, there is network running as a DDE process. We could have hard disk drive like this, sound, USB. DDE is a generic layer, so it should be feasible. DDE itself is a project which is more or less shared by various micro-kernel projects. At ForceDem in February, people agreed that we should have a common library DDE, which is really maintained. We are using 2632 Linux drivers, essentially because DDE hasn't upgraded to 3.10 interfaces. It's something that we would have to maintain, but at least this work can be shared with university projects which are using DDE. So that should be quite nice. Now, maybe we can really have a GNU system that would be gigs over a Hurd. There have been some experiments with NICs over Hurd, so it does work at least a bit. Probably there are things that have gotten broken, but it's a matter of fixing that, and then using the gigs packaging, we should be able to make a real GNU distribution. On the Debian side, could we manage to make an official release of Jessie? I don't know. It will be hard. It's a matter of joining, essentially. And then you can have your own pet project inside all of this. It's essentially thanks to pet projects that gives ideas of how you should make a system flexible and actually make a way for new ideas and to be invented. So don't hesitate to discuss. So thanks for listening. There are some links to the GNU project, the Debian GNU page. There's Michael Bank's slides which provide some background, some history about the Hurd development, so mostly what happened before what I've said. And you would say that yes, my packet is going through the firewall, etc., etc. It's less and less clear that this is really an issue because processors are going are quite fast, and context switching is fast as well. And anyway, the bandwidth is mostly limited by the access you have and not by the overhead you have. And anyway, you have a lot of cores, so it's the CPU usage is not necessarily an issue actually. Thanks. Yeah. So the question is whether we still consider porting the Hurd on another microkernel than MAR. So the long answer is on the wiki. There is a whole page about this. So there used to be Coyote OS, L4, etc., etc. They have never really gotten to further than I execute the process and it prints something. The thing is, you can decide between being pragmatic or fun, and personally I prefer continue with GNU-MAR because we know that we can do something with that. At FOSDEM, in the microkernel development room, there were a lot of projects, and I actually realized that the Hurd was one of the most pragmatic ones among them, and that can actually be used on an everyday life if you are fine with not having sound. While all the other ones would have drivers, for instance, but they don't have this and that, and they don't use the GNU library, so libmath is not the same, so a lot of applications won't compile, etc. So if somebody wants to spend time on doing another port, that's fine, because it's already layered in a way that you have another directory along MAR in the GNU library and in libpside, etc., and then you develop. So fine. It's up to the choice of people doing it, and my choice is continuing MAR for now. Yes? Yeah.
Who is developing your Hurd? Is it only volunteers or is there
Oh, it's only volunteers, yeah. There used to be some developers paid by the FSF, I think, a long time ago, and it's not since 10 years or something. I don't know the details, but it's described in these slides. I don't know anybody who is actually doing Hurd development for university. There has been some Hurd experiments for the university. I don't remember who it was, the migrating threads stuff. Well, some Hurd hacker indeed made his master thesis or something on something around the Hurd, but it actually didn't end up into the Hurd because it was mostly research experiment and not really integratable as such. From times to times we receive mails from people who say, yeah, I'll make a business with the Hurd, etc. That doesn't go further than that. Yes? Say it again? How is network support compared to Linux? Well, basically all the drivers between 2632 and 310 are not in NetDDE. Some of them can be just taken and then copied, and they might compile. Mostly that would be for quite recent cards. For instance, this laptop is fine with the drivers we have on 2632. It is 2 years old. Possibly a strange laptop that you would buy somewhere and just new wouldn't work, but quite a lot they are compatible with E1000 or RTL 8139, things like this. So it's essentially not really a problem. Say it again. Ah, do we have wireless? There used to be a patch in Mach for PCM-CIA wireless cards. It should be still working. Of course, we are not using these kind of cards anymore. Nobody has worked on integrating drivers from Linux for wireless. It's a matter of doing it. Again. Yeah.
I really haven't followed the Hurd in recent years.
Mm.
I kind of heard a few years ago that some of the previous developers offered the opinion that there was some fundamental problems which
Uh,
could be overcome.
Yeah, so I guess you're referring to the critic of the Hurd that was Marcus Brinkman with Neil Wolfid. Um, so, which said there are fundamental issues in the design of the Hurd, which is true. The thing is, it's a bit overemphasized. That is, as soon as you provide access with the machine, then you have a question of resources, how much CPU you allocate, how much memory you allocate, etc., etc., etc. So yes, in an ideal world, we should revamp the architecture to deal with resources management so that it is accounted in a much safer way. I don't think it's a good idea to do this because that would take a lot of time. If you compare with Linux, Linux has exactly the same problem. So do we want to be perfect and eventually not release anything? Or do we want to do something which is quite nice, comparable to Linux, working a bit slower because flexibility has a cost, but fine enough? I prefer managing to release something.
I hear you. I think you're saying then
Yeah.
is that in fact they are not fundamental problems, but they could be overcome, but it's just a question of
Overcome at the cost of revamping the architecture, so that would mean another system, and perhaps we can probably reuse a lot of the previous system, but the IPC would have to be done another way, for instance.
but that would not break all the existing translators, for instance, or would it? I don't know.
Well, for instance, there is the thread migration ID, which is that when you make when you read a file, you make an IPC to the X2FS, and then X2FS does stuff for you. And the CPU time is accounted for the X2FS process. And that's not a good idea, because actually it should be the quota of the user which is decremented by this CPU usage. And so the idea is that instead of letting the thread in the X2FS do the stuff, the thread would migrate to the process of the user and do things inside the process of the user, and then being accounted for the user.
So in that case, that particular translator would have to be considerably changed, but
Yeah.
most of the, in the rule, it would not mean that every userland translator will broken if we were to go down that.
Hopefully, yes. I don't know. I haven't read it all of the Hurd, so I cannot give an answer. but I believe that what they were saying is that it's not so easy to have transparent compatibility. Okay.
Thank you, Ken.
Thanks.